Hey everybody, today we're doing water ripples again. So my old video on it was really popular, but I've been getting some comments and suggestions and stuff that say it doesn't work anymore or they've been having troubles with it. So I figured with a new 5.0 version would be a great time to kind of come back and re-record it and do it all again. It will be mostly the same, but the math on the shader side will be a little bit different. So the ripples will also look a little bit different, but it's all similar enough, you should be able to just build the shader from the old video in the newer version, and it'll probably look about how it did in the old one, because it doesn't need to change much. It's just can be slightly different, but it doesn't need to be. So the ripples in this one will probably be a little less noisy and a bit longer, like if we look at them here. They'll come around a bit further, whereas the old one tended to be a little bit shorter and a little bit noisier. And you can kind of even replicate that look with this shader if you kind of fiddle with it and tweak it enough. This is the project file, which I will have uploaded to my Gumroad. It will be from Blender 4.5. It should work with versions both older than 5.0, as well as 5.0 and versions after it. Hopefully. We'll see. Let me know in the comments if at some point the project file breaks. Additionally, it will include these 3 different shaders, actually 4, you see in front of you. So there's the basic one in the middle that just has the ripples and nothing else. It simply puts the ripple mask into a mix node, which mixes the ripple color and the water color together, and that's all it does. It will also support displacement that works in both Eevee and cycles, but that's it. There's nothing fancy going on. It's just the simple ripples. Then I will have a kind of stylized water with extra effects on top, so it'll be still going after the kind of stylized water look, but it should be a little fancier. I might go over at the end of this video roughly the basics of how to build this, but I'm not going to do an in-depth kind of step-by-step how to build it, because that it will take too long and is beyond the scope of this video. If you want to see that, then go ahead and let me know in the comments. I will also have this little shader here. This one just uses the water ripples to drive the alpha and height of a shader, so it kind of gets a sci-fi ripple effect that could be used on force fields or whatever effects your shields may be. In fact, I might even make a video kind of going into more ways to use this at a later point, kind of like the one I made forever ago. This one also adds some glow to it, so it kind of looks a little more sci-fi, but you don't really even need to do that. Then, on the other side, I will have a more realistic shader. Ironically, this is probably the simplest shader out of them. It mostly just uses the ripples to drive height, and then it has a noise kind of also driving some height and bump that makes it look ripply, and then it has a dark color and low roughness, and that's mostly it. I also mix just a tiny bit of noise into the ripples to kind of give the water sort of a water foam look, but it's honestly fairly straightforward how that's all done, and I might also walk through that at the end of the video. Now, I've kind of gone over this. Again, you can download this as a project file from my Gumroad. Any kind of donations would be super helpful and appreciated, but totally not required. One thing to note is if you give less than $1 via PayPal, it kind of just gets all taken by fees, so I wouldn't recommend doing that. Just hold on to your money or donate via a different method. Now, let's go ahead and hop into just a normal startup 5.0 file and have a look at how to do the ripples. So, here we are in a default file. Let's go ahead and start off by deleting the cube. In fact, let's just delete everything. We'll get ourselves a plane, scale it up by maybe 4 times, make it a little bit larger than default. Hey, future me here. Don't do what I did and make sure you remember to click Control A when you have just the plane. Right after you scale it up, click Control A and apply the scale. It's very important, and it will mess things up if you don't. As you will kind of see in the video, the ripples look a little bit weird until I remember to apply the scale. So make sure you click Control A and apply the scale. Also super important. I would also make sure you do it to all your collision objects, just to make sure it doesn't mess anything up. Okay, return to the previous man. Unfortunately, in 5.0, the beta I'm using does not support the screencast keys add-on, so I will try and kind of explain what I'm doing, but I might miss some stuff, and I apologize for that. But to start off with, we're going to click Tab, go into Edit Mode, and subdivide the plane a bunch of times. Now, the more you subdivide it, the higher fidelity the effect will be, but it will also be slower and harder to render. If you're covering a very large area with it, you may want to go a little bit less subdivided, but it may vary in quality a little bit. So just kind of keep in mind what your use case is and plan accordingly. Then we shall add a UV sphere, move it off to one side, and let's add a couple just random cubes. These are kind of just going to be our random geometry that will see the effects of the ripples. So we're going to try and make it just a little bit interesting to look at. but it doesn't matter too much. Then we'll select all of our objects we just added, click M to add them to new collection, and rename it collision, because this will be what our ripples are being created by. Now it's in its own collision, so let's open up this bottom bar, click the little button in the corner, click G, and that will take us to the geometry nodes menu. Then we will go ahead and select our plane, click new, and we have a new node tree on our plane. Then we're going to add a store named attribute node, add it to the chain, and in the empty slot we're going to type gradient. This doesn't actually matter what the specific name is, you can call this whatever you want. However, you will need to make sure you type in the same thing in the shader. So we'll click enter to confirm it. We're going to go to the outliner, click and drag on our collision collection, drag it into geometry nodes, and drop it. We're going to change it from original to relative, and then we'll drag out of the instances socket and type in realize instances. This will basically take it from being instanced geometry into real geometry that Blender can evaluate. It changes some of the math and how things are calculated on the back end. This node is very important. Don't forget to add it, because it will not work without it. Then we're going to add a geometry proximity node. There it is. So we'll go ahead and connect that into our train, move it back a little bit. So what this will do is we'll take each face on our plane and check how far it is from the nearest face on the geometry in our collision collection. Which means if we look at this face here, it will be, say, 1 unit from this face on our sphere. And then the face right here will have a value of 0. So we have a 1 to 0 gradient going this way. And what we want for our ripples is to go the other way. We want the closest faces to have a value of 1, and the farthest ones to have a value of 0. So to do that, we just need to remap our distance value to be opposite from what it is now. And to do that, we can use a map range node. We want our distance plugged into the very top socket that's called value, and we just want to invert the two bottom numbers. So we go from min will be 1 and our max will be 0. And that will take it from being a 0 to 1 gradient to a 1 to 0 gradient. Now we'll just plug the results of that into our value of the store named attribute node, and that'll be it for geometry nodes. The from max value will change the max distance our ripples spread. So if you want to change them, you can change this value, but keep in mind as you change this value, it will also change all of the math in our shader node. So make sure to set this before you tweak all of your values to perfection in the shader, otherwise you'll mess them up when you change it. Let's go ahead and just drag out of the from max and plug it into the empty slot below the geometry in our group input. And we can just call this distance, or let's call it spread. And now, if you go into the modifiers tab, you can see we have that as a value that we can change on the fly whenever we want without having to dig through our geometry nodes. So, we're going to click the little top corner button again, and this time we'll click S, and that will take us to the shader editor. Let's leave edit mode and click new, and this will add a new shader to our plane. Then, we're going to create an attribute node. In the socket, we're going to type whatever we typed in our geometry nodes. So for us, it will be gradient. Make sure you spell it exactly the same. You can even copy paste the value. Then we'll take the color and drag it into base color, and let's switch over to the rendered view so we can see if it's working. I'm also going to switch over to cycles so that we don't have to wait for the compiling shaders, but you should be able to use either render engine with this effect. It should work fine. Let's go ahead and zoom out a little bit. We will uncheck scene world and scene lights, that way we can see what we're doing. Now, as I look at this, it looks like it probably is spreading a little bit further than it did in past versions of Blender. Let's go ahead and try just turning down our spread value a little bit. And let's, instead of plugging it into the principled shader, just Control-Shift-Click on the attribute node so we can see exactly what the values are without the shading messing it up. Now, it looks like these are spreading very far and not actually getting down to 0 as the values. So let's go ahead and turn down the spread some until we start seeing kind of black areas appear. And that should work right there. And you want this to just be set however far you want your ripples to spread. It doesn't particularly matter, just do it before you tweak all of your shader settings. Let's start on actually building the shader. To start with, we need something multiplied by our gradient value to actually cause movement. So we need to get time that we can add as an offset. So let's start by making a value node and typing in hashtag frame into the empty slot. And what this will do is we'll create a driver that will just match whatever number in this is to the current frame. So if we drag out here, so if we create a timeline here, it seems like in the current 5.0 beta, the timeline is just missing or they moved it somewhere and I'm not seeing it. Either way, for our purposes, Graph Editor or any of the other ones will work. But you can see as we move where the thing is, the frame we're currently on, so currently we're on 40, will match whatever value we have in the value node. Because the value going up by 1 every single frame will probably be way too fast for whatever effects we want, so we need to remap that value to be much slower. How we will do this is we'll drag out of the value node and type in multiply. This will get us a math node set to multiply, which we can then add a very small decimal point into the value. So for this, let's start off with like 0.05. Alright, this multiply we added will determine the speed at which our ripples radiate. So we'll call this one ripple speed by just clicking F to add a frame node, and then we'll call it ripple speed. And then we'll plug that into a math node that is simply set to add. So we'll drag the factor out of our attribute into the top socket and our ripple speed into the bottom one. Then we will create a vector math node and we'll plug our add into the top socket of that, and into the bottom socket we need to create noise. Now what this will do is essentially we'll take a noise texture and add it randomly to the gradient value that we have, which will essentially do, if we take a single circle going around this value, we're going to basically take the noise texture and add to random parts of it and subtract from other parts of it. If we take, say, the noise texture has like blobs that are roughly yay big, then we'll take those blobs and when we add to them, so if the noise texture is white, it'll move them further out, and if they're black, it'll move them closer toward the center. And this will kind of distort and randomize our ripple pattern so that it isn't quite as regular. How we'll do this is we'll get a noise texture and we'll plug it into the bottom socket of the vector math node. Now, the reason we're using a vector math node instead of a normal math node is because we're using the color socket of the noise texture, which has 3 values, RGB. It technically does not make that big of a difference, but I found in my testing that the look was just slightly smoother when I used the color input and a vector math node instead of a normal math node. You could also use a normal one, it doesn't matter too much, and you can experiment and play around with it and just see what works best for you. It really does not matter that much. I would encourage you to take this effect and just play with it, see what you can get it to do. It's one of the best ways to learn. Now we're going to drag out of the value node again and get a second multiply. We're going to set our noise texture to 4D and plug the value of that into the W that has now appeared. What this will do is it will evolve the noise randomly without moving it over time. We're going to take the value of that and also set it to something really low. Let's try 0.01. That will slow it way down. Now, let's go ahead and give ourselves a little more room again. Changing the scale on this will change the scale of the noise inside our ripples. So it'll make kind of the distortions bigger and smaller. Now, out of the add node, we're going to create a second noise texture. And we want it plugged into the vector value. This one, the scale will change the overall size of each of our individual rings. So the bigger it is, the longer each ring will be, and the smaller it is, the closer to just basic noise it will be. And you'll kind of see that as we go. In fact, let's go ahead and preview that, and you can see we pretty much have the overall ripple shape we're going for. What we need to do now is increase the contrast, because we don't necessarily want this many ripples in each of our ripples. And then we also need to get rid of all of these extra areas that kind of go in between the ripples, because we don't want them either. To do this, we're going to start by adding a color ramp. Put it in front of our noise texture, and we're going to drag the black value in to increase the contrast. And you can already see that's looking a little bit more water ripple-y. Let's also change the scale on our first noise texture to be a little bit smaller. Let's go down to maybe 2. And let's also turn the detail down so it's not quite as grungy. And now, to get rid of the areas in between, what we will do is add another math node, and we will set it to multiply. Then, we'll take our initial factor out of our attribute, which if you remember, has our ripples, and then it has black everywhere in between the ripples, and we will multiply it by our fancier water ripples. What this will do is we'll take everywhere that is black in the initial gradient texture map thingy, and we'll keep them all black. So that way everywhere in between all the ripples will stay black. So if we preview that, you can see it's isolated the ripples very nicely. One thing we might want is to smooth these out some. We may not want them to be quite as harsh in their fade out. So we're going to duplicate our multiply, and we'll just add a second layer of multiplication over it, for which we will add another color ramp. And we'll plug the factor into this one. And then we'll multiply it into the second multiply node. Then we'll change it from linear to B-spline, and then we'll just drag the black value in a ways until we like kind of the fall off. So let's go with that. Another thing this will do, if you're using height displacement, is it will make the fall off smoother. So the ripples right next to the collision objects will be much higher than they are right at the edge where they kind of disappear. It'll kind of add a smoother fade out. So now we only have two things left to do. One is to add color to it, for which we can either use a color ramp or we can use a mix node. The simpler method is to just use a mix node, set it from float to color, and drag our value into the factor. What this will do is it basically says everywhere that's white on our texture, take the A value, everywhere that's black, take the B value. So for our whites, we're going to want them to actually stay pretty much white because that will be the color of our ripples. We'll brighten it up. And for B, we want it to be our kind of watery bluish green color. We'll drag that into the base color and then preview it. And as you can see, it seems like our colors are way too bright or something's gone wrong. Let's once again, with Shift-Tab click, preview our multiply and make sure everything's going right there. We can see that looks good. Let's preview our mix. Okay, so our mix is actually inverted. I did it wrong. We want our A value to be our watercolor. So we'll set that to the greenish blue color we want for our water. Let's also darken it a little bit. And then we'll set our B to our... we'll set B to our ripple color. So we can just turn the saturation down and the value up to create white. And now, if you want these to be brighter, let's add a way that we can, at the end of the process, just increase the overall brightness of our ripples without actually getting rid of our black and whites. So we'll add a third math node. This one will also be set to multiply. If we increase the value on this, it will brighten the ripples without raising the black level. So as you can see, as we turn this up, the ripples just get brighter, but our water stays where we want it. Now let's also tweak the second noise texture just a little bit more as well. We can try maybe turning the scale up. So that will kind of create more and less ripples. Let's actually turn the scale on our first one up a little bit. I kind of want them to look a little bit noisier. I think that's pretty good. Let's actually turn it down on the second one to get fewer ripples. And then we can, oh, that might be too far. And then we can increase the contrast on our color ramp to get a couple less. There we go. And again, if you want to see the exact settings I ended up with on the project file, you can download it and dig through those shaders and really dig into them, have a look, see what you can figure out from them. They're a little complicated, but all we have left to do is to calculate the height for this. So we'll add a displacement node, and then we'll take our before we did our ripple brightness multiply, so we'll take the center multiply and we'll plug that into the top value of the displacement or the height. Now we'll plug displacement into displacement and we'll see what happens. I think we also will need to turn it on. Click N to pull out the side menu if it's not there. Go to Options, Settings, and we'll switch it from Bump Only to Displacement and Bump, or Displacement Only. I don't remember which one. I think Displacement Only and Bump only works in cycles and is not EV supported, but either will get you displacement. That didn't seem to do much, so let's go ahead and try turning up the scale. And now you can see that instead of our ripples going up, our plane goes down an equal amount. And why this happens is because if you think about how height maps work, you have mid-tone gray right in the center, and then usually anything that is white on your displacement map goes up, and anything that is black on your displacement map will go down. So what we need to do is take everywhere that is black on our ripple texture and move it upward so that it's 0.5 gray for the displacement. In order to fix this, all we need to do is add a map range node. We'll add it right before the displacement, and we'll take the toMin, because this will be the minimum value that our texture will have, and change it from 0 to 0.5. Now you can see it's hopped back up to the correct level, and if we increase the scale to maybe something huge so we can see it, you can see the plane doesn't go down and the waves go up. Now, if you wanted to layer in like normal water waves on top of this, you'd probably want them to go down and up so that it averages out to the same height, and you would want to add that after the map range. That way you only affect the waves without actually changing how the ripples work. Scale down to a more reasonable value. Let's try 0.2, maybe 0.4. There we go, you can kind of see that. Let's also, for playback purposes, see if I can actually get this kind of smooth for the video. Let's actually unsubdivide our square. That might be a little rougher, but it should play back a little quicker. Let's also switch over to Eevee and see if once the shader compiles, maybe we'll get a good frame rate and you kind of see what it's doing. Alright, so you can definitely see how subdividing the plane more will get better results, especially if you're using displacement. We can also add a subdivision surface after the geometry nodes. That way we add more resolution to the mesh that gets displaced without adding more resolution to the mesh that the geometry proximity node has to calculate. Because that is part of why it gets so much slower as you add more geometry, is because that is exponentially more vertices that the geometry proximity has to calculate. So as you can see, it's kind of doing what we want, but it's going really fast. So what we can do is make the ripple speed value even smaller. So let's change it from 0.05 to maybe 0.01. And that's closer. It's maybe a little too slow. I think we're also doing a little too much with the displacement, so we can turn that down. Let's try 0.3, maybe even 0.2. And I think we actually want to make the ripple noise. So if you, as you can see, if we make the scale on the noise texture too big, you'll kind of start to just lose the ripples and it'll kind of just become straight noise. So you want to make sure you stay small enough that that doesn't happen. We can also, I think it's being a little too warbly right now, so we can probably turn down the speed that this noise texture evolves. So if we change it from 0.01 to maybe 0.005, that'll roughly half it. Now you can see it's not kind of as jittery, it's a bit more stable. Another thing we can do to kind of make our ripples a little bit smoother and less grungy is change the detail on our second noise texture to also be 0. Now, something I've just realized, and hopefully I will put a big note early in the video so that you don't run into this as well, but it's also very important if you do that we can fix it. So, if you remember when I changed this value, it's also kind of making what we have now a little bit funky, and that is because I did not apply scale to the plane. It's really important to also remember to apply scale to the plane. So we can reset the spread value to 1, and now let's kind of just roughly tweak. So if we make this a little smaller, set this to 4, and now I think you'll see the ripples have a much more pleasing look. So make sure you remember to apply the scale. I will also make it earlier in the video, so if you, with your foreknowledge, have seen this video and are confused why things look a little different throughout, it is because I do not apply the scale. And now that we've applied our scale, we can also probably turn our scale on our displacement up a little bit, make it a little bit larger. I'll probably go with something like 0.5 for just a little bit of an exaggerated effect, but also I think it looks pretty nice. And that concludes the basic how to do the general overall ripples. I will hop in just a moment. I will hop in and do more kind of rough explaining for how the other shaders work. And again, if you want to see them more in depth, let me know, and maybe I can make a video about them in the future. If you have any questions, concerns, or comments, feel free to hop down below and let me know. I will try and answer as many as I can. One question I've gotten asked a lot in the past, and that is, can you use this in a game engine? And the answer is kind of. You can't use this straight effect into a game engine, but you can rebuild the same math and it will work inside a game engine because it's all just mathematically based. So as long as you can replicate all the steps, you'll get pretty much the same result. The important things would be having a gradient that detects where things are. So you need to find some kind of way to detect edges where different objects are overlap or are nearby. I know Unreal has sign distance fields is the most common way to do that in Unreal. I'm not sure what Unity has, but I've seen people do it. So I know it's possible. I do not know the exact method. But once you have the gradient between different objects, then this math here, the important bits are adding the gradient to the speed and then adding that to your displacement of some kind. The way to do it in a game engine would be take your time, add that to your gradient, and then multiply that by a sign field. I'm not sure if that's entirely correct. I know one of Prismatica's videos about sign distance fields talks about it, and in that video he shows pretty much exactly how you get the basis for the effect that I've done here. It just doesn't have the noise on it, and you could probably figure out how to do that, but if you're just in Blender, then you can use exactly what I did here. I also wanted to shout out real quick that if you're interested, I also make minis over on the website Thangs and sell them. So if you want to help support what I do other than these tutorials, go ahead and follow my link tree and check those out. I'll also link it in the description. Here we are in the project file, and I will do a quick little walkthrough for some of the shaders that I have here. As I said, the middle one is pretty much just exactly what we built in the tutorial. The one up here is just exactly what we built in the tutorial, so the little sci-fi ripple shader. But I take the final value out of the ripples, so this is our ripple mask, and I plug it into the alpha, and then I also just add a little bit of color and strength to the emission. That's the only thing that's different. Other than that, it is pretty much exactly the same as our default ripples. The two more complicated ones, let's start with the realistic one. So let's kind of break down how this effect is done, because it's done in a few layers. The main one is simply just a noise texture that gives us the base ripples in our water. How that is made is it's a noise texture that has the same little multiply plugged into the W of a 4D. That just means it evolves slowly over time. And then in the vector slot we have a mapping node, and in the location of our mapping node we have a combine XYZ that just separates the XYZ locations and into only the X, so that way it only moves in one direction. We have again a multiply that's plugged into our value node, which is just time, plugged to the X, so that way it moves slowly over time, and then is rotated so it moves in kind of a funny direction that's not just perfectly along an XY direction. That texture is pretty much just plugged straight into a mix node that goes into the displacement. What this mix node does is it mixes the ripple mask, so basically just the black-white version of our ripples, with that noise texture, and that's kind of how we layer the ripples into the waves. Then, the only other thing this texture does is we kind of generate some ripple foam, which is just a noise texture that's set to really big. Again, we can kind of preview it. And what this one has into the vector is, again, just a mapping node with a mix. That mix mixes the vector that's just a default UV, and it takes the output from our vector add node with the noise in it, and it just kind of mixes in a tiny bit of that, so that way you can see it's sort of distorted along the shapes of the ripples, but it's a very subtle effect, and honestly you wouldn't even need to do that. Then it's plugged into a color ramp, which just increases the contrast, and then it is multiplied by the ripple texture, so that we only really see it where we have our ripples. Then that goes into the set water color, so you can see in most of the water we have it set to just a dark greenish color, kind of a lake color, and then we've got kind of our foam color that determines where the foam is. We also have that same exact mask going into the color, as well as a color ramp that makes it really dark and white, and that goes into our roughness. So this makes it so that on the sort of ripply foam it is less rough, and where it's just water it's more rough and shiny. So we can preview the whole thing together, and as you can see, the foam is really subtle. It's not very obvious. We can even clamp this a little bit more, and then you can see it's kind of getting less shiny, but that doesn't look particularly good. So it's a super subtle effect. You could even just get away with just using the initial noise and the ripples and get a very similar overall look to that. Then finally, the most complicated shader is ironically our complex stylized shader. This one has a couple layers going into it. First off, you have large scale waves, which we can preview, which is just a big noise texture. Then into that, we have foam that only appears on the peaks of those waves. Then we have two stacks of these caustics. The first one is multiplied by the overall large wave color, and what this does is it makes them slightly darker in the troughs of the waves and keeps them at their full brightness at the peaks. Then that goes into a set of mix nodes. The first one, using screen blend mode in a mix node, mixes the ripples over the caustics, and then the second one subtracts the second layer of caustics, which again are just a Voronoi set to distance to edge. It subtracts that from the first to kind of add detail and some more variation. So you can kind of see if we zoom in, how the second layer is very subtle and only sort of appears in some locations, but it helps a lot create a lot of kind of organic variation that makes it look a lot more pleasing than if you just had the one layer. Although if you didn't want to, you could leave off the second layer and kind of simplify things. Then, right here, you can see this is just our default ripple shader. And then this kind of line of mix nodes is what actually combines all of the different effects together. So the first one, again, reduces the caustics in the troughs of the waves. The second one mixes the ripples and the first layer of caustics. The second one subtracts the second layer of caustics via multiply from both the ripples and the first layer of caustics. Then the wavefoam, using add blend mode, is added on top of that. So this is just the foam coming out of this little section here. That is what creates the foam on the very peaks of the waves. Then we set the watercolor, which is just exactly how we did it in the simple shader pretty much. Then we darken the troughs, so we take out of our final result for our waves, we come up into a color ramp that we tint the dark spots of slightly green, and the light spots we kind of just darken, and we overlay that using overlay blend mode in a mix node on top of our watercolor. So as you can see, this kind of just darkens the valleys a bit, and if you leave this lighter, it will also lighten the peaks, but we kind of do that in a different way, so we leave it for now. Then we take a second color ramp, which is out of the same exact spot on the waves. The second color ramp, the dark color is set to kind of just a mid-tone gray, and the light one is set to kind of a sunny, light green color. And this we color dodge on top of our watercolor. That way it brightens the peaks in a very nice, kind of satisfying way that's more interesting than if we just made them a slightly lighter color. So you can see it kind of goes like a sunny, almost like there's sun shining onto it. Then finally, the last layer is we mix in kind of a reflective, sort of pseudo light color layer, which you can kind of see if we move it back and forth. That's these patches here that are like extra light. And this is also being color dodged on top. And this is driven by just some kind of hacky specular that kind of works. You may or may not want to use it for your stuff. If you're using Eevee, then you could use a shader to RGB, put it into a color ramp, and get the same sort of effect that would actually react to lights. Whereas this is just entirely faked by reflecting, using a vector math node to reflect the normal and the incoming ray, which is, it sort of just gives you a pseudo light effect. Which if we look at it, you can see it's got a bunch of different colors that kind of mimics how light would react. Then we separate color, and we take just the green channel. Additionally, we put it through a mapping node that if we use the rotation on the Y and X, it kind of remaps which way this looks like it's coming from. And that way it sort of closer approximates light. Then we put it into a color ramp that super crushes it all down and makes it really contrasty. And then again, we color dodge that on top. And for another little quick breakdown of how the waves are made, it's just the same thing that we did with the Voronoi, where one multiply goes into the location. This one is plugged into the X and Y, so it moves diagonally of the mapping node. That is plugged into the vector, the noise texture. And then we have an additional multiply coming out of our time that goes into the W scale, so the waves evolve over time. Then that's plugged into a color ramp to increase the contrast. We can look at what that looks like, and then we increase the contrast some. Careful you don't go too far. If you crush this so that it is too clamped, you'll start seeing flat spots on your highs and lows, so do be careful of that. Then that noise texture goes into a clamped the other way color ramp, and this just extracts just our highlights. Then we use that as a mask on where to show our smaller wavefoam. So you can see that's once those are mixed together, you just have waveform on the very peaks of our big waves. And I think that pretty much covers everything. I know I moved quick and it was a pretty confusing shader. Hopefully this was helpful to at least some of you. If you got confused or lost in there, you can download the project file and really move through it slowly and follow all the different threads and really figure out how it functions. Another thing, you can use more complicated meshes on the collision. Like you can use photo scans or whatever else. All you have to do is place it into your collision collection. And that's it. It should just work straight out of the box then. I think that's everything that we're going to cover. Again, if you have any questions or comments or concerns, go ahead and place them down below. And thank you so much for watching. I will see you next time. Bye-bye.